Hello. We are going to start Unit 3 today, and we're going to look at periodic relationships, periodic functions. So let's just dive right in and talk about them. So, a periodic relationship between two variables occurs when the output values demonstrate a repeating pattern. I'm just reading there over successful equal length intervals. So that's what we call a periodic relationship. The period of a periodic function is the length of the x values that it takes for the function to complete one cycle. Now you may ask, what's the purpose of this? Well, one of the big purposes is the fact that there are periodic relationships found in nature all over the place. We can begin by looking at the tides, the way the tides rise and fall. If we graph those are periodic. If we look at, temperature patterns, especially in Kansas where we are, those would be periodic because we have the four seasons. So the four seasons are exactly periodic as far as average high temperature goes. And we could go on. There's so many different periodic functions, blood pressure, just so many. So the first thing we need to do, though, is to make sure we understand the basics of what a periodic function is. So in this first example, we can tell that this thing repeats every 4 units, starting at -1 to 3, and then from 3 to 7. So that is a periodic function with a period of 4. So now we're supposed to draw 2 additional periods for the graph. Well, that's not hard. So I know that I got to go 2 over, 2 up, then 1 down, 2 over, 2 up, then 1, then down, and then I can just put those in there. There you go. Hopefully yours is better than mine. Now, looking at this one, now that gets a little dicier as we go through this. What's the least possible value of the period of g? Okay, well, you can look at this any way you want. Pick any point and look for where it repeats. Look when it repeats. Well, if I take this point, it repeats at 6. So that period is 5 units, right? But I could also pick here and then here, but that's also 5 units. It doesn't matter where you choose the points. When it starts repeating, it will be the same period. So the least, let's clean that up a little bit. The least possible period of g is 5. Okay, now knowing this then, and I'm going to erase these, we can figure out what value of g, any value of g, based upon what we have just in our graph. So in other words, okay, let's look at g of 14. What would g of 14 be? Well, you kind of can extrapolate this out if you wanted to, but that would take a while. But we know the period's 5, right? Well, 2 times 5 is 10. So what if we did 2 times 5 plus 4? Well, that would be 14. We know that this is 2 periods, right? So it's going to repeat starting at 4 then. So we can kind of dismiss the 2 times 5 and look at g of 4, and g of 4 is 7. So g of 4 equals 7, which is also what g of 14 is. Okay, similarly, g is 72. Well, let's see, if the period's 5, what if I do, 14 times 5. Let's do that. That's 70, isn't it? Yep, plus 2. So that would be, again, 14 periods. So 14 cycles, I like to say too. 14 of these, right there to there. 14 times leaves you with g of 2, and g of 2 is 6. Okay? Now, you may be asking me, where am I coming up with this? You can pick anything that works to this number right here, as long as you have it in terms of 5. It's just a linear equation, really. So, for instance, how could I get negative 17? Well, let's see. In terms of 5, 20 minus 17, or should I say 3 minus 20? There we go. So 3 minus 20, there's 4 periods here. You don't have to write this period thing out. I'm just doing it because it helps the thought process here. That means that's g of 3 because this is all going to cancel out because you're repeating. So it's basically g of negative 17 is g of 3, which is 7 again. Okay, so this might be a good time to stop and think about what we just did. Okay, now we can also do, we just did that with a graph. Well, now we can do it with a table. Okay, well, this table says that H is periodic. It has a period of 5. Find the following values. Okay, now remember, period's now 5. So we need to get negative 2. Well, 3 minus 5 is negative 2. This is our period, correct? So we can kind of dismiss that and go h of 3. Well, h of 3 is there, so that's 0. Okay, what about h of 6? Hopefully you're saying 5 plus 1, because that's 1 period. Okay, this is 1 period. So the plus 1 is all we have left. H of 1 is negative 2. It does get harder, okay, trust me. What about h of 9? Well, h of 9, sorry. Well, we have to work inside out. So we have to work inside. So h of 9, you can see that 9 is not up there, the x, but 5 plus 4 is. That's 9. Well, 5, again, is 1 period. So that means h of 4 can be used, and h of 4 is 3. But then we need h of that, so h of 3 is 0. So these are composite functions from, 2 months ago, 3 months ago, when we did composite functions. Now D looks complex. H of 5k minus 3, where k is an integer. Well, we know this is my period, right? That's our period. So we're looking for h of negative 3, basically, because h of 5k minus 3 is really h of negative 3. So how do we make negative 3 with a number that's up here? Well, 5 minus 8, but 8 isn't a number in the x. Let's see, what else could we use? 7 minus 10, and 10 is 5 times 2, right? So 2 periods right here. So we could do h of 7. There we go. And h of 7 is 2. So h of 5k minus 3 is always 2, no matter what number I use for k, because it's periodic. Okay, well, here's another one, and it's good to understand this, that we need to X that out. It's useful to have notation to model periodic phenomena, okay? And a periodic function starts with a basic pattern, and then it translates that pattern over and over and over its domain. So it's actually just a horizontal translation of itself. So with a period of 5, h was 5, the period of h was, we can translate it right 5 units, okay, every time, and it has the same graph. So notice, looking at graph F there, that graph would just complete itself over and over and over every 5 units, okay? So the graph of F is periodic with a domain of all real numbers. 2 full periods are shown. Find all the input values of F that yield an output of 1. Okay, well, in this case, this example went with this problem up here. This example goes with example 5. So we need 1, right? Well, there's 1, there's 1. So 2 and 6. Well, that's a period. That period's 4, right? So the period is 4. So let's see. How would we find every 4K, right, is going to give us 1. It starts at 2. Well, how do we get 2 from 4K? Well, if K was 0, it'd be 4K plus 2, right? Because 0 times 4 is 0, 0 plus 2 is 2. Let's see, put K as 1. 1 times 4 is 4 plus 2 is 6, so that works. So our x's then would be found by taking 4K and add 2 every time. Now this K can be anything. We can go backwards too. We can make K negative 1. If we make K negative 1, then it's negative 2. 1, 2, and there's our graph. And you can see that it would be accurate. And let's see, K is 0, 1. If we said 2, it would be right here, which would be 10. 4 times 2 is 8. 8 plus 2 is 10. So we did it. It's accurate. Okay, now, deep breath. The last model that we're going to look at for periodic models is probably the most important, okay? This is something that we're going to see many, many times, specifically on the AP exam. This is actually an old free response question task model. We have several examples of these to practice. Once we do a few, it's going to make a lot of sense, okay? So we have a large clock mounted on the wall. It's 120 inches off the floor, okay? So let me put this in perspective. It says it's 120 inches off the floor, I think. Yeah, the center of the clock. The hand of the clock is 8 inches, okay? And the clock's not working. Instead of going around every 60 minutes, it goes around every 30 minutes, okay? So think about that. When the minute hand goes around, it completes an entire cycle in 30 minutes instead of 60. Now, if we graph this, we will get something that looks like this. So that's 2 full cycles. So 1, 2. So you can see 2 cycles. Now 5 points are shown, F, G, K, P, but we can put a bunch more on there too. In fact, I can put points right there and you can see them. So that's 2 full cycles, okay? But we're going to label 5 points, F, G, J, K, P, and we're going to talk about them. Okay, so at time t, the minute hand is pointed directly up at 12. So at time 0, we are going to start at 12, which is right here. Well, then 3 would be G, 6, 9, back to 12, 3, 6, 9, correct? Okay, I hope that makes sense. So then it says, okay, we want to know possible coordinates for these 5 points, F, G, J, K, and P? Well, let's see. F could be, well, it's time 0 because it says T, H of T. I think it's H of T. Is it H? Yeah. So our time is our X, our H of T is our height. Well, what's our height there? Well, if you said 128, you'd be correct because it's up here. There's F. Now remember, we're moving this way. So what's G? Well, G is now, well, let's go to 6 quick. How long does it take to get to 6? I hope you said 15 minutes because it's doing its half, remember? It goes around in 30 minutes. So J is 15, so G must be 7.5 minutes. It's halfway in between. What's that height right here? Well, if you said 120, you'd be correct. So what would J be? Well, 120 minus 8, which is 112. So I bet you can figure out K and P now. You'd add 7.5, and you'd add back on 8, and then when we get to P, guys, we're at the same place. Because remember, our period is 30 minutes, so it repeats. So you can see how the cycle repeats from F to P. Hope that makes sense. Now, it asks, refer to the graph again. It says G coordinate is time sub 1, basically is what that means, T sub 1, and J is T sub 2. Describe on the interval what's true about H. Well, H is the function itself, that's this graph. Is it positive or negative? Well, it's above the ground, so it's positive, right? So that eliminates C and D. Now, is it increasing or decreasing? Well, from T1 to T2, it's concave up, right? See how it's concave up from here to here? It holds water. It's cupped up. But you can also tell that the slope is negative and getting less negative. So, but it's negative, right? So that is a decreasing function then. So it's positive, but it's decreasing. It's going down. However, let's talk about the rate of change. What about the rate of change? Well, the graph of H is concave up, right? So that makes the average rate of change, what do you think? If you said increasing, you'd be correct. Why? Because it's getting less negative, remember that? So we have to relate all this stuff we've learned in the past. So the rate of change from T1 to T2 is that it's actually the average rate of change is negative, but it's getting less negative, it's concave up. So therefore, if it's concave up, it's increasing. All right, if you have questions, make sure you ask. Thanks.